So I'm just going to touch on a couple of things here that are important. One is the purpose for this article in this class is to show you how these system ingredients and components interact. And in the case of food systems, to show you that there are significant physical and non-physical dynamics going on, as I introduced earlier. And as we do this, we need to understand the basics of the system. So let's start with some of these systems signals. So here we go. One of the first things that you're going to recognize in a systems diagram are the rectangles, right? Those are stocks. You're also going to recognize in this particular diagram red and blue lines. Red lines represent balancing feedback or reducing the flow or the buildup of things. Blue lines are going to represent the amplification or the reinforcing feedback of systems dynamics. In the case of this diagram, they are not going to use flows or delays in this diagram. So you won't see flows between stocks. What you're going to see are causal loop lines. And so these particular diagrams, unlike your Earth Systems class where we had stocks and then flows and then causal loops that connected the stocks with those little decision valves on those flows, in this case you're only going to be looking at causal loop dynamics. So you're only going to be looking at balancing feedback and reinforcing feedback and some signals that are coming in to inform that feedback as to how fast those behaviors are going to take place. So let's move on to the next discussion, and they start off, I'm going to skip this section here, but they start off with a very simple diagram just to show you what reinforcing feedback looks like by itself. And this is how our agricultural production system really took off. It took off with technology, with machinery, with the invention of the cotton gin, with the invention of combines and tractors that could pull large plows down the field. So mechanization is what reinforced food production and food efficiency. Right? So that's kind of the first one. The next one, they begin to throw in how natural resources put a check on that mechanization, and that was the diagram I showed you earlier. So these balancing feedbacks show put a reverse amplification effect on the reinforcing feedback of technology. And so as the natural resources degrade, it slows down production effectiveness and production efficiency. And then this next diagram begins to throw in the component of knowledge. These researchers had found scholarly evidence that the knowledge that producers have or that they possess to organize food production is one of the most critical inputs in the system, next to their use of food production inputs like machinery, and next to ecosystem resources which create the productivity of a farm. This next diagram shows you how supply and demand works. And so as we had more machinery, we increased supply and price went down. But as you add in other signals, notice those signals are coming in a straight line: consumer purchasing power, per capita consumption for health, per capita consumption for lifestyle, quality of food. All those are signals, along with the stock of population, the stock of food available for consumption, and the stock of agricultural land. All of those inform this balance of supply and demand. And then when you throw in food availability, the number of farms into that equation,